Hey guys, so we're looking at continuation of yesterday's lesson of working with linear um, equations, and we had a bunch of rules for that when we used multiplication property, and also the addition property, and we also looked at reciprocals. So today's lesson is pretty much the same topic. It's just dealing with how to remove fractions and decimal numbers from the equation, so it makes the question a little bit easier to deal with. So if I share my OneNote with you guys. Let's sort of go to the left top here. I'm just going to turn off my video. And so we can see here that there's a bunch of rules or suggestions that we should deal with here. So I'm just going to read them quickly here, but you can go back and go over them again. And so we look at multiplying both sides of the equation by the LCD. We use distributive property when multiplying brackets. Combining like terms by using the addition property to isolate the variable. And it's preferred that we get the variable on the left side at some point, but you don't have to do it right away. You can wait till the very end and just flip the equation around, which is what I like to do. And then we also use the multiplication property to make sure the coefficient in front of the variable is 1. And using the reciprocals method works quite well. And of course, at the very end, you should always check your solution to see if you're correct. So I have a statement here. So I guess this is zoom in here. So we got I get it, zoom in. So we have 1/2 plus 9/6 equals 2. So is that a true or false statement? And let's see if we can do that without using a calculator here. And then we'll start talking about this idea of multiplying through by the LCD here. So when we look at this type of problem, it is helpful to not work with fractions if you can. And that's the nice thing about equations, is that whatever you do to the left side of the equation, you can do to the right side, and that makes things work out quite well. So one way to prove this, I guess, would be to just work with fractions. Just do what we normally do, and that's find lowest common denominator, add these things together. So we have a 2 and we have a 6, so the LCD would be 6. So if I times the bottom by 3, I times the top by 3, I get 3/6 plus 9/6. That's supposed to equal 2. And of course, when I add fractions, I add the numerators. So that's 12/6 equals 2. And of course, 12 divided by 6 is 2. So we say 2 equals 2. And we are happy because that seemed pretty straightforward. Now, the reason I'm showing you this is not to do that kind of math, because I know you guys could do that kind of math, but to actually look at the statement in a different way and think, can I prove this in a way that would get rid of the fractions? So I'm not actually using fractions to prove the statement is true here. And once again, if you use this idea of finding a lowest common denominator, which is 6, and what we can do is we can multiply through by that. So I'm going to kind of use the notes we have here about of what to do, like what you do here. So I'm going to times this side, I'm going to put that in brackets. I'm going to times that side by 6, and I'm going to times this side by 6. Now, because I've got fractions, it is helpful to write 6 as it would be as a fraction, which is 6/1. Not so important on the right side because we don't have really a fraction over there, but I'll write these as fractions just to show this is true. Now, of course, if I do 6 times 1/2, that would be 6/2. And I know 6/2 goes to 3. So why not just say this is 3? So you see, by doing that multiplication there, we've gotten rid of the fractions. That's quite a little useful technique. So we have to do distributive property when we have brackets, though. So I have to times the 6 by 1/2, but I also have to times the 6 by 9/6. So 6/1 times 9/6, well, that would be 6 times 9/6. Now I could do 6 times 9 is 54, but why do that? Why not just say 6 divided by 6 is 1? And that would just leave me with 9. So I can cancel out the 6's really, which makes the math quite nice. And of course, I did make a mistake here. What was I saying here? Sorry, that's over 1. Sorry. So 2 times 6/1 would just be 2 times 6, which is of course 12. And you can see in doing that one step, that idea of multiplying both sides by the LCD, I've gotten rid of my fractions, which usually makes the question much easier to handle. Like, I mean, most of us are quite comfortable with integers. When it comes to fractions, we're maybe a little more apprehensive with what to do in those kind of questions. So this idea of multiplying through by the LCD will fix that problem for you. Now, it only works with equations, so you have to have an equal sign here to make this work, because 3 plus 9 is 12, and 12 does equal 12. So to me, it seems like the proof is quite a bit easier than the fractional proof of it. Okay, so here's two questions we're going to work on. I'll just shrink that down a little bit so you can see both sides. So the first side here says solve this equation, solve this equation. So I'm going to pause the video. And why don't you do this idea of finding the LCD and multiplying both sides by the LCD? Okay, so if you've done that, let's see if you're right here. So for the first question, it's kind of a replay of the last one. The LCD here is, once again, 6. So I'm going to take everything here, and I'm going to times this left-hand side by 6, and I'm going to times the right-hand side by 6. So when I do that, I'm going to make it over 1, just so I see that it's a fraction. Of course, that's over 1. Don't make that mistake again. So we know 6 times a half would be 3, so I'm going to distribute that in. So that would be 3. Bring the plus sign down. 6 times x over 6 would be 6x over 6. So it would be 6x over 6. And the 6's would cancel, leaving me with x. And 2 times 6 would be 12. Now, using my addition property, so that's sort of mentioned in the rules here, the things you want to do here. So you want to use addition property. So to use addition property, I'm going to move the 3 over. So I'm going to have to subtract by 3 because right now it's being added. So subtract by 3. And now that would leave me with just x on this side. And then 12 minus 3 would be 9. And you can plug that back in pretty quickly to check that. But we know that from the previous question, it is 9 actually. Okay, so here's another question here. So let's take a look at our LCD again. So the LCD for this question, well, we've got 3s, we've got 2s, and we've got 6s. So the LCD happens to be 6 again. Not always going to be 6, of course. And then I'm going to take this and times it by 6 over 1. Take all of this and times it by 6 over 1. Now remember, you have to do this, where is it here? This second rule here. You have to be careful with the distributive property and how you distribute numbers into brackets, because it's very easy to make a small mistake here. So when I do the left side, I have to do 6 over 3. So 6 over 3. What would that give you guys? Why don't you try to figure that out? Maybe see where you get there. Okay, well, 6 over 3 is 2. So this would be 2 multiplied by 2x plus 5. Because notice that 3 would go into that 6 twice. Okay, now if I distribute this into the brackets, I'm going to get equals 6 over 2, which would be 3. 6 over 2 is 3. And in the next one, I would get 6x over 6. So if I times that by that, I would get 6x over 6, which is just x, so plus x. Now what's going to have to distribute? So I have to distribute that in. So that's going to give me 4x plus 10 is equal to 3 plus x. Now here I have a question where I have x's on both sides of the equation. So I'm going to use my idea of grouping like terms. So once again, you can move the terms however you want. I prefer to move them in a way that reduces the number of negative signs. So I'm going to subtract x from both sides. Subtract x there, and I'll subtract x here. And remember, I'm minusing 1x when I do that. So 4x minus 1x is 3x. I got to bring the 10 down. And now this side, the x's would cancel, leaving me with just 3. Okay. So now I have to move the 10 over using my addition property. So I'm adding 10 to the left-hand side, so I need to subtract a 10. Subtract 10. Of course, when I do that, I'm left with my 3x now. And then 3 subtract 10. So you're starting at 3 and you're taking 10 away. So you're going to be at negative 7. Okay. And now I need to isolate the x value here. So I need to multiply by a third to both sides. Or you could think of it as dividing by 3. But I find sometimes, because it might be other fractions, it's maybe better to say let's times it by a third. So I'm going to times it by a third. And so I would get 3x over 3, which is just x. And remember, this 7's over 1. So I would get negative 7 over 3. Now, if this multiplying by the reciprocal seems kind of, strange, you could just say divide by 3. But I'm trying to get the idea that if you multiply by the reciprocal, it actually is the same thing as dividing by 3. So multiplying by the reciprocal of the number makes it a 1. Okay, so our question here involves some decimal numbers. Now you could turn these into fractions, like you could say this 9.009 is 9 over 100. 0.13 is 13 over 100. And that's it for our decimal numbers. So it seems like we're going to be multiplying by 100 here. Some of you might also realize that if you just multiply by a factor of 10, you move the decimal 1 unit. So to move the decimal in a way that creates integers, you're going to have to move the decimal 2 units, which means you'd have to multiply by 2 tens. So multiplying by 100 then. So I think I would do multiply by 100 first. I like the idea of working with integers. They just seem much easier for me to work with. So I'm going to take this side of the equation, and I'm going to times everything in here by 100. And I'm going to times this side by 100. So remember, whatever you do to the left side, you have to do to the right side. So I'm just going to make this a bit bigger, and I'm going to times this in. So I'm going to times that by that. So that's going to give me 9x. And then I'm going to times this by that coefficient, which is going to give me 13. Now there's still x plus 10 here. So notice that I don't put it into those brackets. Maybe I'll do an example on the side here why that's true. Let's finish the equation off here. That's equal to 20 times 10 is 200. Sorry, 2000. Okay, so now I'm going to do some more distribution. So I'm going to say that's 9x. I then have to distribute this into that to the binomial. So that's going to give me 13x. And then I'm going to go plus 130 is equal to 2000. So let's group our x's together. We've got 9x's and 13x's. So that's going to give us 22x plus 130 equals 2000. And so now we're basically have a question like we had the day before. So I'm going to subtract 130 from both sides. Now these numbers are getting a little bit bigger, so I think maybe a calculator would be useful. 22x equals. Now if I subtract 2000, sorry, take 2000 and subtract from that 130, I get 1,870. Okay. And now I could multiply both sides by 1 over 22. But because the way the question is, there's no fractions here, I'm just going to just say divide by 22. So I divide that side by 22, and I divide that side by 22. And that gives me x. And now 1,870 divided by 22, I think that goes in evenly. It does, yes. That's 85. So that actually would be fairly easy to check that by just plugging it into the equation. Okay, we have one last problem to do here. Once again, the idea is, how do we get rid of fractions or decimal numbers just to make the math a little bit easier? And so generally it's multiplying by the LCD. That's your first big step here. Okay, here we go. So let's read this question and try to decipher what we're being asked to do here. 30 less than 25% of a number is the same as 1/10 of the number. Determine the number. Now, if you say it really quickly, it doesn't make a lot of sense. There's a lot of words in here and a lot of things you got to pick apart to make sense of how to set this thing up. But let's start with our basic thing here. Is they're talking about some number. So let's just say let x equal the number. So that's what you're trying to find out. Now, if you want to be more adventurous and choose a different variable like n, for the number. That's cool. You could do A or B or C, but just make sure you understand what your letter stands for. Some people default to X, and that's just because most people are uncreative, but most of you guys are creative. You guys are a super creative bunch. So pick a letter you like and then just say, that's what I'm solving for. That's the number I'm looking for. Okay, so let's pick the question apart. I like to circle, underline things that mean something to me in math. Less than, so less than. So if I'm going to think that's maybe two different things, you can have less than symbols, but in mathematics, I'm thinking we're doing some subtraction here of some sort, so we're minusing something. I know 25% as a decimal number is 0.25. So that's what 25% is. I know 1/10 is a fraction, so that'd be 1/10. And then I know the word is, generally in math, that means equals. So we've got something like on the left side and then is, and then something on the right side here. So let's see if we can pick this apart. So 25 less than a number. So so if I said 3 less than your age, so what is a number 3 less than your age? Would you, let's say you were 16, would you do this? Is that 3 less than your age? I don't think so, because that would be like a negative number. So if you were 16 and I subtracted 3 and I said that's 13, I think I could say 13 is 3 less than your age. So we got to be careful how we write the subtraction ones. So 25% of a number, well, that's 0.25. So 0.25x, so that's 25% of the number x, less 30 is 1/10 of the number x. So here we see x's on both sides of the equation. Now, to get rid of the 1/10, I could just multiply by 10. That would do it. But if I multiply 0.25 by 10, I get 2.5. So I might multiply things by 100 here. So I'm thinking the LCD would be 100. Now, of course, if you turn a 25 into a fraction, you can easily see that now, because 25 over 100 is 0.25. So the LCD is definitely 100 here. So I'm going to take this side times it by 100. I'm going to take this side times it by 100. I might just write this over 1 because there's a fraction there just to make sure I don't make a mistake with the math. So the left side, I've got to do some distribution here. I got to distribute that in. So that's going to give me 25x minus 3,000 equals, now this would give me 100 over 10. So I know that is 10. So this would really be 10x. So let's group our like terms here. So I'm going to minus 10x from both sides. If I do that, I get 15x minus 3,000 equals 0. Let's bring the 3,000 over. So I'm going to get 15x equals 3,000. And then you could times both sides by 1/15, or let's divide both sides by 15. So if I do that, I should get an x value of 200. So the number that we're talking about, the number is 200. So the number is 200. And that's a word problem for you. So I'm going to call that a wrap. I'll put some questions online for you guys to work on. Basically, this unit is identical to 6.1. It's just that you're trying to get rid of the fractions or decimal numbers first, and then it's really the same question. So if you haven't seen the video before this, you really should go through that first. Otherwise, this might not make a lot of sense. So please check the Google Classroom for the homework that's posted, and good luck with that. Okay, so let me just stop this and stop the recording.